In continuing to learn about new types of graphing concepts and expanding our abilities to graph different types of functions, asymptotes are going to be very important. So it's asymp with this P, a lot of people forget this P, asymptotes. And an asymptote is basically an imaginary line that a function cannot cross. So let's say I had an asymptote right here on my graph. Now this just goes all the way up, 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 down, 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 and let's say this blue line is the graph of my function. Now as the function gets closer towards an asymptote, it goes, I can't cross the asymptote. It's impossible. So it starts leveling off here, and it will just keep going closer and closer and closer to the asymptote, but it will never cross the asymptote. We also might have a graph coming on from the right side. This one might go downwards and go, asymptote, run away, but it can never cross. It will just keep going right up alongside the asymptote. Alright, there are three different types of asymptotes. Let's go ahead and start with a vertical asymptote. A vertical asymptote is just an asymptote that goes up and down in a vertical direction. Next up, we have a horizontal asymptote. You might be able to guess. This is just an imaginary line, an asymptote in the horizontal, the left and right direction. And lastly, we've got a slant asymptote. A slant asymptote would be a diagonal asymptote of some sort. For example, an asymptote that goes like this. To find vertical asymptotes, I want you to ask yourself an important question that I first asked myself as a small boy. What makes my denominator 0? So, looking at this function here, we have f of x equals x squared plus 5 divided by x minus 2, x plus 3. Here we have my denominator. I see that if I have a value of x equals 2, my denominator will be 0, or if I have a value of x equals negative 3. X equals negative 3. This is very similar to one restriction that we have on our domain. But anyway, we have x equals 2, x equals negative 3. So if I was going to go ahead and put these asymptotes on a graph, I would just have the asymptotes at x equals 2. That would be one of my vertical asymptotes. And I'd have an asymptote at x equals negative 3, another vertical asymptote. To find the horizontal asymptote is a little bit more complex, but not too bad. You are going to have a horizontal asymptote when the degree of the numerator is the same as the degree of the denominator. For example, here we have f of x equals 3x squared minus 2x plus 1 divided by 4x squared plus 12. Remember, the degree is the biggest degree in the expression. So here we have 3x squared. Down here we have 4x squared. Since the degree is 2 for both of these have an x squared term, there is a horizontal asymptote. Here we have 2x to the 6th as our leading term. On the denominator, we also have x to the 6th. So this also has a horizontal asymptote. Over here, here we have x squared times x plus 1 times x minus 2. Remember, to find this leading term, we're going to have to multiply the first terms out of each of these. That would be x squared times x is x cubed times x is x to the 4th. So the numerator has a degree of 4, as well as the denominator, this 5x to the 4th. So this also has a horizontal asymptote. Now your horizontal asymptote is always going to be the ratio of the highest degree coefficients. That's just going to say, take your coefficient of each degree and put it as a fraction. So for this first one, our horizontal asymptote, our coefficient is 3 on the top and 4 on the bottom. So our horizontal asymptote is y equals 3/4. And if I was going to graph that, I would just go up to about 3/4 and I'd put a horizontal asymptote. Next, we've got 2x to the 6th over x to the 6th. The coefficients would be y equals 2/1, or just 2. And if I wanted to graph that horizontal asymptote, I'd just go up 2 and do my line at y equals 2. Lastly, here I've got x squared. Remember, this x squared times x is going to give me an x to the 4th leading term on top over 5x to the 4. So my horizontal asymptote is going to be at y equals 1/5. And if I was going to graph that, again, I'd have it really close to the y equals 0, but about there. Alright, we're going to be taking a look at some special cases. Not that regular horizontal and vertical asymptotes aren't special, because we're all special in the eyes of God, but these are just some cases you want to pay particular attention to. The first of which is when the degree of the denominator is greater than the degree of the numerator. For example, here we've got f of x equals x squared plus 1 over x to the 8th. The degree of the numerator is 2. The degree of the denominator is 8. The denominator degree is bigger. Here we've got a degree of 3 on top. Here we've got a degree of 5 on the bottom. Again, degree in the denominator is 0. When this is the case, you've got a horizontal asymptote at y equals 0. In this case, your horizontal asymptote is y equals 0, which is just a horizontal line at y equals 0. Our next case is when the degree of the numerator is 1 more than the degree of the denominator. Here we've got a degree of 3 on top, which is 1 more than a degree of 2 on the bottom. In this case, we have a slant asymptote. Remember, your slant asymptote is a diagonal line. I'm going to talk more about that in just a minute. Lastly, when the degree of the numerator is 2 or more bigger than the degree of the denominator. For example, here we have a degree of 6 on top. Here we have a degree of 3 on bottom. 6 is 2 or more bigger than 3. So in this case, we have no asymptote. This is just going to indicate to us that there is no asymptote on the graph. Alright, finally, slant asymptotes. How to find your slant asymptote, remember, is if the degree of the numerator is 1 more than the degree of the denominator. Here we've got a top degree of 3, a bottom degree of 2, so that's 1 more, so we know there's a slant. What you need to do is set up a long division problem. If I did this, I'd have 2x cubed divided by x squared plus x minus 12. And if I want to make it a little easier on myself, I'm just going to add some 0 degree terms in here. Plus 0x squared plus 0x. And I can go ahead and proceed. Now remember, long division, I'm looking for what times x squared is 2x cubed. That's going to be 2x. That's going to give me down here 2x cubed plus 2x squared minus 24x. I go ahead and I subtract everything. That's going to distribute, cancel out. It's going to give me negative 2x squared plus 24x. Alright, what times x squared gives me negative 2x squared? That's going to be minus 2. Alright, now this is where you can stop. All you have to do is to do 2 terms, because this is what we're going to be focusing on for our slant asymptote. Our slant asymptote, in this case, is going to be a line y equals 2x minus 2. So I know in long division it can get a little tedious, but you only need to find 2 terms, and then you can stop and write what your slant asymptote is. And remember how you graph this. A line is in y equals mx plus b form. My y-intercept's at negative 2. My slope is 2 over 1. That's up 2 over 1. I put another dot. And my slant asymptote is going to be a line just like that.